Assalamu alaikum students, hopes you are all fine. Today's our topic is ratio test. We have the series A of n. It is the series of positive terms and we suppose that the ratio between the two terms A of n plus 1 over A of n, if we are applying limit n approaches to infinity on the ratio of two terms, and if this limit is equal to L, where L is a non-negative real number or infinity, then we have three categories or three options. If L is less than 1, the series converges. And if we say if this L is greater than 1 or infinity, the series A of n diverges in this case. And the third one is if L is equal to 1, the test fails to determine convergence or divergence of the series. So we have 3 points that if this L, limiting value of the ratio of this series, if this L is less than 1, then the series is converges. And if this L is greater than 1 or infinity, the series diverges. And if this L is equal to 1, then we simply say that our test fails to determine convergence or divergence of the series. Now we are taking example that we have the series A of n, it is equals to n power 4 over 2n. Now simply we are taking the ratio between two terms. You can see it in this example. You can see it this example that A of n plus 1 over A of n. Now A of n plus 1 is the term n plus 1 whole power 4 over 2 power n plus 1. And A of n is the term, here we are taking its reciprocal as A of n plus 1 is divided by A of n. So simply taking its reciprocal. Now here we are taking this term and this term common, and you can see it 2 of n and 2 of n has been cancelled. So we simply have 1 by 2. Now we are applying limit n approaches to infinity, then this will become 1, and we have simply limit 1 by 2 which is less than 1. So according to this definition, we can say by ratio test this series A of n converges. Now another example is investigate the behavior of the series. Now we have the series A of n factorial whole square over n square whole factorial. Now you can see here the A of n plus 1 term is n plus 1 factorial whole square over n plus 1 square whole factorial. Now we are taking its ratio with A of n, taking ratio between two terms, and here we can see it that after opening this factorial term, it is n plus 1 minus 1 factorial square. Now as you know that factorial is equal to n into n minus 1, n minus 2 up to 3 to 1. So according to this definition, we are opening here factorial term. Now n square factorial, it remains same, and in the denominator we are opening n plus 1 square minus 1 factorial and n factorial whole square. Now here you can see it that n plus 1 square, this square is applying on both terms. N plus 1 square, here n factorial square and n square factorial. Now in the denominator we have n factorial square, it will be cancelled with this term, and simply we will have only this term n square factorial and n plus 1 square minus 1 factorial. Now we will open this factorial now, and this factorial will be open in this form n plus 1 square minus 1, n plus 1 square minus 2, n plus 1 square minus 2n, n plus 1 square minus 2n minus 1 factorial. And you can see it that this term will remain same, this term will remain same, but at the end this term will become n square factorial. Then this n square factorial will be cancelled with this n square factorial. So we will have now 1 over n plus 1 square minus 1, n plus 1 square minus 2, up to n plus 1 square minus 2n. Now, when we apply limit n approaches to infinity, then this ratio will be approaching to 0. And this 0 is obviously less than 1. So, by the ratio test, we can say that the series converges. Now, I have the exercise. Exercise is your 8.3, in which you will have to attend question from 1 to 10. I have solved one question number 1 for you. Here we have the series 2 of n over 2 of n factorial. Here a of n is this term, 2 of n over 2 of n factorial, and a of n plus 1 is 2 of n plus 1 over 2 of n plus 2 factorial. Now simply taking their ratio, and this ratio will be after opening of the factorial term, 2 of n plus 2, 2 of n plus 2 minus 1, 2 of n plus 2 minus 2 factorial. Here it will be cancelled out with this term. As you have seen that it will be cancelled out here, and this 2 of n is cancelled with this 2 of n plus 1. So we will have simple 2. Now it will be cancelled with this term, and we will have 2 over 2 of n plus 2, 2 of n plus 1. Now as we apply limit n approaches to infinity, then this ratio will become 0. So the given series converges by ratio test. So student, you try to solve other question. If you have any problem in question, then discuss with me. Thank you.